Good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Hi everyone.
Halo Pak.
Waalaikumsalam warahmatullahi wabarakatuh. Hai Pak.
Waalaikumsalam. Good afternoon, sir.
Okay, thanks for the answer. Thanks for responding to my greeting. So this is our fourth meeting. So we will talk about dynamic graphics. And as for today's discussion, that will be more about the hands-on. So please, I'm sorry, the music is too loud. So I would need you to prepare your VS Code by now. I have shared my live share link on the Discord live class channel, text channel. So you can go ahead, go there and click on the link. And also if you want, you can also stop my stream and prefer to simply follow my codes in the environment in the live share code page, and follows my slides progress at class point if you want to save your bandwidth. You are welcome to do so. And it's also because perhaps my stream is not really good because lately we got some problem with IndiHome and Telkomsel connection, and I'm using that provider in my at my home. Okay, so I would like to start with the presentation first. So let's take a look on the first slide. As the brief description in this particular occasion, in this particular meeting, we will talk about the event loop and then some ways of handling event through the document object model, and one of them is add event listener. This method is very important. You need to understand how it works so you can manage to draw the dynamic graphics on your application. And later we will also try to implement the codes so that our application is able to to allow our mouse, our keyboard, our input devices to interact, to manipulate the graphics that we have drawn on the buffer. So that's my promise for today. So after finishing this session, I hope that all of you have confidence to, in simply speaking, to draw or to animate any objects using WebGL. Okay. Now, let's move to the second slide. I would like to review the previous discussion. In our previous meeting, we have not in the third meeting, I mean in the second meeting, so it's last two meetings. So hopefully you still remember. Maybe I need to move to the, I'm just kind of out of the screen for now. So you hopefully you still remember that we have finished the part 1 and 2 in the second meeting. And for today, we would like to put more focus on third, fourth, and fifth steps of this activity, of this preparation, not preparation, this is activities purely activities that we need to accomplish to implement any computer graphics applications, especially using WebGL. And the number 3, 4, and 5 may need to work with what's so-called event loop. And that's one of the subtopics that we will cover today. Now, let's continue our review to the third meeting last week. On last week meeting, hopefully you still remember that we built quite a simple application. We drew a triangle and also rectangle in the end, right? So this rectangle was static. So maybe I would like to remind you again. So I'm just gonna go to the VS Code right now. You can open your VS Code as well. So we are now in our learn WebGL project that we have stored in the GitHub repository. I think I need to move to the. Okay, so in this GitHub repository, if you do not have it in your local computer, so you know how to respond, then you need to clone it again, etc. I will not show that. So assume that all of you is now having this project in your local computer. Now open that application or that project again and give it a try to run it. I believe that the vertices is already in rectangle. Yes, correct. So there are two triangles. Okay, there are two triangles. I'm sorry, this should be D with the .abcd. If I run this, let me go live. So this is what you got when you run the application that you have written last week. Let me open the inspect. So maybe I'm just gonna put it. Oh, just okay. Maybe I'm just gonna put it this way. So let me open the console. Blah blah blah. I think it's okay. So this is the rectangle that we drew last week, and it is static. Now imagine that you would like to rotate this square, the square that you have drawn last week. How to do that? To rotate, then you need to maybe utilize or make use of a theta and then some trigonometry. Okay, this is one of the simple algorithm that you may apply. You can put this is the way storing the vertices data and transfer them to GL array buffer. Last time we put it like out of the iteration, but now suppose that, give me a moment, this one. Yeah, because we want to do some animation, it means that we need to change some variables with respect to these vertices variables particularly. And to change it, you can use the iteration mechanism or looping mechanism. So you have some increment. Okay, increment process in here. So you add up the theta with some delta theta. So you can specify this above the for iteration loop. And then you rotate it with using the trigonometry. So this is the way, one of the way to rotate a square. And once you have completed assigning the new values for your square, then you deliver these changes through the buffer subdata. We haven't yet tried this method, actually, this function, but I believe you can understand it pretty quickly, because it's basically just buffer data but with some offset. So in a buffer data, if you rewrite if you call the buffer data again on the same array buffer and the same pointer, I believe that you would need to rewrite the whole vertices. But in this case, we only rewrite part of the vertices data that we have stored in GPU array. In case that maybe you have a lot of objects in your application and you only want to rotate your square, then the way to do that is to transfer the data changes through this buffer subdata. You can explore in more detail about this in the WebGL documentation. I will not cover this. And it's just for example. Later, for our course, for our assignment, I think it's good enough to simply use the buffer data. And then you need to you need to render. So which means that this render function is basically the function containing gl.draw arrays or gl.draw elements. So that's the function button. These render functions. I will show you in practice in example in the next slides. And you need to do it again and again. And it is possibly kind of infinite process. So it's infinite mechanism. So it won't stop. So you will do it again and again until you close the application. So that's simply how it works. However, this simple algorithm may spend quite a lot of resources. Okay, quite a lot of resources. So it's not efficient. It's not efficient. And to do it in more efficient way, you can actually make use of the uniform. Okay, and this is the way that I will teach you today. As for the vertices data, you just need to send it once. So just in the beginning. So once you have delivered your vertices data to array buffer, then that's all. So you have finished transferring the data, the vertices data, and what the next things that you would like to do is giving some uniform that basically supplies some transformation, some changes necessary for the vertices to pay attention to. And our shader will help us to manage adding up this uniform value to the original vertices data that is captured through the attributes variable. Hopefully still remember that. So in the end, our GL_position will be the combination between your vertices data that is captured by attribute variable inside the vertex shader with the uniform variable indicating the change that this position should go with in every single frame that we would like to draw. So we only send the theta, for example, or some simple variable. So we do not necessarily to send the whole and to put the burden of calculating the maths, the computations on the processor. So instead, you can give this responsibility, this computation jobs to GPU instead. And even though actually it doesn't matter whether it's going to be CPU or a GPU that would need to take care of it, I think the performance is not really different. It has a big difference, so it's okay. But in terms of codes, I think it's more cleaning. If you do not have any, especially if you do not have any special library that you will use for the computation, then you can simply choose this option for calculating or computing the transformation, the change in the shader. And then after that, this is the computation with respect to the theta. I think I've just explained about that lately. So the last one, you may need to render this computation, the GL position that you have been computed, that you have computed through the render loop. How to do that? We will learn about that in this session. Now, let's get our hand dirty. We may need to move to the code in JavaScript. Now, please open your Visual Studio Code. We will try to implement I think we will not use the rotation because we need to specify the sinus, cosinus. Maybe we just try to apply some simple translation instead. Okay, so go ahead, open your Visual Studio Code again. Now let's have a look in our Visual Studio Code. We have the point A, B, C with the color. So I think it's good to go. To have this program to be animated, maybe I'm gonna teach you first how to put the rendering process into a single specific function scope. Okay, so let's see. This is basically the render process is for now consisting of these 3 lines of code. Okay, so let's put these lines of code into the function of render. So create at the bottom of your main.js, please create function render and then put the whole 3 lines into the render functions. You could do it this way. I'm just gonna remove the space to make it simple like this. And then I will, for example, implement. Give me a moment. So let's see the slide first. What is one here? Okay, so for now we need to learn about how to implement uniform. Okay, so once you finish putting your render, maybe we can go back to the top of your page. Not really to the top. Please go to your string your source definition of your vertex shader. Okay, and create a uniform after varying before void main. So I would like to create a uniform in here. The uniform data type will be float, so it's just single vector. Vector in one dimension, just one value. I'm just gonna set it as a float. There is no fake1. There's something like this. No, there is no. So you can just simply use float and then the name of the variable. As a convention, we agree to give this prefix for all the uniform variable that we have. So let's say this is u, and then what is the name of the? Maybe we can use chains maybe. So the chains. So these chains will affect the GL position. So as I said that later, if we want to animate our object, then the GL position should be more dynamic than just simply putting the A position, the attribute variable as its parameters. So instead of just letting the A position alone in here, so I'm just gonna give it some companion, and it is uChange. Okay. So we will transfer some chains to our shader, and this change will change periodically across the frame. So that's how we will work with our shader by now. So after you put the uniform chains on your Vertex shader source code, then you know that you need to create a pointer, just like the A position and A color that we have in a shader realm. This one, we need to create a pointer in the JavaScript side in the CPU realm. The same applies for the uniform. So I'm just gonna create a mechanism, uniform to animate the vertex, the vertices. Okay, and this uniform will apply the same to all vertices that we have registered in array buffer. In here, let's declare it as U, the same name, U chains, and then we need a WebGL API that is called gl.getUniformLocation. And let's see, the program is shader program, and the name of the variable inside the vertex shader is the same, U change. So we will type it like this. Okay, and then after that, this is just a pointer, guys. So you need to give it some value. The same with the one that you have done in C computer programming when you need to create a linked list. So after you finish creating the linked list, that's not the end of the story. You need to allocate the memory, and then you give some value to store on that particular memory. And the same thing apply in here. So let's say that I will separately create some variable in the JS realm. So in the CPU realm, this JS file, and this change will start from 0, and we will kind of increment it. Let's see. Let's make it, for example, let's make it always. We always add up some value, for example. So I'm sorry, I forgot. This render loop is actually, if you run this, I believe that, where is that? So it's gone. The picture is gone. Why? Because we didn't call the render function at all. So to make this function works, you need at least call it once in any place within this main function scope. Okay, and I will put it is just in the end of the main.js in the main function. So it drew the rectangle. It successfully drew the rectangle, but without any chains. Now let's make it like having, but before doing that, wait, give me a moment. If we put, okay, if we put some chains in here, we specify the chains. For example, we do some increment. The chains equal to chains plus 0.5, for example. Just make it rigid. And then, of course, these chains will not affect anything on the GPU because the chains only influence the situation inside the JavaScript file. To register these chains, to register this addition, you need to call gl.uniform 1f. 1f means just a one single value, and it is float. and you will give it to uChange as the pointer. So it means that it will be delivered to the GPU realm, and then the value is the change. Okay, so this value is the change. So imagine that this function is being called, the render function is being called, and then the change when the gl.uniform1f is executed is already 0.5. It means that uChange in the shader is already 0.5. This is 0.5, which means that you can imagine that then the whole position in this vertices data will move or shift to the right, because we not shift to the right. I think she's shift to, give me a moment. So I think it's shifted to the right, top right, because the x and y will receive the same 0.5. Okay, the center of our rectangle was here, and now the center is the right top corner of our frame. Okay. Actually, you can manage to separate the change for the x and the y position if you want. To do that, you can just simply define the fact2 in here, for example, and then you can, for example, this is change x and change y. Okay. And then you may need to add a different value, maybe 0.1 for the x and 0.5 or maybe 0.3, let's say 0.3 for the y. And since this is a 2 value, then you need to use a 2f. Okay, 2f. Automatically, this uniform that is actually in the shader is factor 2 will receive this 2 value. We will put it as the second and third parameter as its values. Okay, so it's a change x and change y. Here we go. So it's the difference shift. It's only 0.1 unit to the right and 0.3 unit to upward, okay, to the top of the frame. So that's how it works. However, the changes only happens once. It's okay because we haven't yet learned about the mechanism to animate. We will need a render loop. I will come into that particular topics in the next slides. So let's just commit this first. So in here we have successfully transfer transitional change to GPU through as a uniform variable, or maybe I just gonna type it uniform. Okay, so this is our achievement so far. I need to speed up because there's a message saying that maybe in the 2:30 we need to prepare. Maybe this guy we need to prepare for the ASIN accreditation. I'm sorry for that. Hopefully we can finish after 1 hour from now. So here we go. We will need to go back to the our slides. Please have a look again in here. So we have let's recap what we have done so far. We have u theta as in here in this case as the pointer to the u theta, the uniform variable in the GPU shader. And we need to fill the theta with some new with some new value in here, and then after that we will store the value to the allocated memory appointed by this pointer, this U data. Apply the same to our code. You can see it here. So the U data is just the U chains in our code. If you want, maybe let's have a try. I haven't yet tried it, honestly. So in here, we can kind of call the function recursively. So render inside render, let's have a try. But I think it's going to be very fast movement. We cannot find anything. Oh, no. Maximum call size. Oh, yes, this is some error. I think that because our execution is too tremendously fast. Okay, very fast, too fast. So we cannot use this way. So I think it's a bit incorrect to present it. But this is just to give you some idea. This is the pseudo code. So do not take it as granted as written in here. So later you may need to transfer to change this mechanism with the event loop mechanism. We will explain about that in the next slides. Let me continue. That was in the JavaScript application. Now let's see how it was in the GLSL. So in GLSL we have the U theta as the uniform variable. We have U chains in our code, and then we put the U chains in addition to the position, the attribute variable that we have for the shader. So it's an additional variable to register the chains upon our position. So this is the idea. Now let's talk specifically about the event loop. Speaking about event loop, by the definition, is kind of a function that is responsible to render graphics, especially event loop in the computer graphics. What is inside the event loop is usually something that you need to execute periodically. So let's say that your computer running on the 30 FPS, which is very unlikely. The current computer, I think, is 50 hertz or 60 hertz. So it's 60 frames per second. Then it means that that render functions will be executed 60 times in a single second. And that render function, we call that as an event loop. This is part of event loop as well, but it's very naive. And as you might see, it doesn't work in my computer because my browser just scream out saying that no, you just use too much memory allocation because you render, you execute these recursive functions directly reflect on the speed of the processor clock, which is that's not a good practice. It's impossible practice even. Okay, so you need to learn about the event loop, or another word will be this is also callback function. So every single thing that need to work as a rendering pipelines, a rendering process should sit on callback function or event loop. In our case, when we do not have this recursive mechanism, actually the function, just like this, sits also on callback function, and the callback function is actually this main.js. This main function. Why? If we take a look back to our HTML code, we register this main function as the callback function of onload. You can have a check in here. So it's basically everything that every function that you will use as for the event loop, as for rendering process, is basically event loop or callback function. Okay. Change this to This one. Okay, now let me go back to the slide. Right. In the case of static graphics, so that's what I was talking about. So as the case for the static graphics, we proceed the rendering process inside document.onloads callback function. However, as our target today, the dynamic graphics that basically can be in the form of looping animations or interactive graphics. Especially the looping animations, we should put this in some event loop. There we need to apply some practical methods to execute some function periodically, and those methods can be in set interval, set timeout, or request animation frame. Let's try to implement the set interval first. So this is the way we implement it. We have the definition of the functions, and after that we need to put the function name as the parameter, the first parameter of the set interval method. And as the second parameters, we may put the frame rate here, for example 60 frame per seconds, as the second parameters. 1000 means 1000 milliseconds. Imagine that you want to build something in 60 FPS. Then you just put this as the divider of this 1000 value. So you can imagine that if we have higher FPS, then the result of this division will be smaller number, right? It means that the computer needs to call this function more quickly, more frequently. Hopefully you can imagine that. That's why it should be the divider of this 1000 milliseconds. So let's have a try. Let's go back to our Visual Studio Code. Now I do not need to open my index.html, so I'm just gonna close it, and I'm gonna back to main.js. Go to the down below to the bottom of my main.js page, and in this particular lines of code, I'm just gonna need to type set interval, and then set the render as the first parameter, and then set the second parameter, the FPS. Suppose that we want to build now, let's say 30 FPS. Let's have a look, and perhaps we need to reduce the chains in here, because otherwise, let's have a check. It's still considered very, very fast, because as you might know, 0.1 because our clip space in the WebGL is between -1 and 1 for the whole axis, for Y, X, and Z. And if I changed it, you can imagine that if I changed it 0.1 after these milliseconds, so it means that when I tab my application, the rectangle is no longer there. So I believe that we need to reduce these numbers. For example, I may put it as 001 and 003. I think perhaps it will. You can see it right now, right? So here we go. This is the rectangle. It is moving now by 0.001 to the right and 0.003 to the top, going upward. And you may find that it's kind of shaky. And if you want to create a smoother animation, then actually, as I indicates in the FPS explanation, then you need to just simply improve or increase this value. Set it as 60 maybe. So it's going to be 60 FPS. So it's very smooth. It's even smoother in 120. Right? So it's in 120. But as you might realize that the speed also changed Okay, the speed is also changed, so we need a strategy. Suppose that you want to maintain the FPS and you just want to or maybe you even want to play with the both FPS and the speed. In that case, then you may take it this way. So, for example, I think it's a good idea to specify the speed. Okay, or maybe the FPS first. So let's see the frame rate. The frame rate over here. The frame rate will be let's see, standard 60 now. And then I will set this frame rate in here. Wait. Maybe I need to put it before the uniform. So before the command of this uniform, I specify the frame rate, and then I may specify the speed. That's the speed for the speed X maybe. The speed X will be. I think I need the speed X raw. For example, speed X. It's speed X raw. It's a kind of, for example, one. I can use integer now. I think using integer is better because later we will combine with the frame rate, so it's okay. So I do not necessarily to set the speed raw as float under 1. Less than 1 or between 0 and 1. So let's just make it this way, 1. Then I can maybe later demonstrate if it is 2, 5, 10, and so on. And as for the speed X, let's say that this speed X raw will be divided by, let's have some specific number, maybe something like this. And give me a moment. If the FPS is wait, or maybe it's not for. It depends on the frame rate, and then with some other division. This is very optional. Okay, so basically you need to incorporate this frame rate value in your computation for the speed X. Or maybe, guys, wait. Speed X. Let me show you. Maybe it's a good occasion to show you the. I'm just gonna use speed maybe. Speed is kind of. Wait, I'm a bit confused. Let me type. Let me make it this way first. So speed X. This will need to specify this one. Okay. Change X is change X plus speed X, and change Y. We will need to declare it this twice. Not twice. I think it's once, but for every axis. So speed Y. We have frame rate. We have speed X. Let me specify this as 3, for example. And the Y is 1. And then this XY is here. Speed Y is here. Okay. And now, perhaps it works already. So here we go. If I improve the frame rate, for example, 120, the graphics become smoother, but yet still with the same speed. Oh yeah, with the same speed. So I maintain the speed in this case. So it doesn't matter what frame rate that I use. Maybe for just one frame per second. So it's gonna be like this. Okay, so this is 1 frame per second. Or if you want to make it 10 frames per second. So you can imagine that is the same speed with the different frame rates. And what frame rates that you may need to use, this is quite arguable because every monitor has its own hardware specification. Majority of modern monitor today use 50 hertz and 60 hertz as its frame rate. And as for example, the Quest, what is that? The Oculus Quest, the VR headset, they use 120 hertz right now, 120 FPS for the display. Its display technology frame rate. And as for the standard in television, cartoon animation in television, for example, is 30. So it depends on the case. You may choose according to your specification, your requirement. And let's see that majority of for the computer usage. So I'm just gonna use this as 60. And later, actually, you do not need to care about this frame rate. Because later I'm just gonna suggest you to use request animation frame, because this particular function will help us to check the optimum frame rate for our device. For now, we need to specify it manually. For the set interval and for the set timeout, we need to specify the frame rate manually. Okay, now let me put the way we compute the thing in a vector way, because it's a vector too. So I would like to demonstrate this. So instead of having speed x raw, speed y raw, I'm just gonna call it speed raw and define it as this. Okay. Speed raw is just, this is a vector. This is how we define a vector in JavaScript. So it's simply an array, actually. And as for the speed, but in this case, we need to manage it manually, just like the one we manage and the one that we manage in standard C programming. It's a different with the shader. In the shader, you can just extract the x and y value from the speed raw. For example, if you want to take the 3 and 1 all together, you can also do it this way, right? In shader, but unfortunately in JavaScript it doesn't work. So you still need to use the traditional way to access the array element. But basically, if you want to represent any vectors in JavaScript, this is one of the way to do that. And then the speed, let's make it. I'm not quite sure whether it works or not. Let's have a try whether it works or not. Can we divide the array? Let's check with console.log and let's see if the speed. Oh, it's error. So we cannot do it. So it should be manual, or maybe yeah, but it's easier to read it this way, right? So maybe I'm just gonna take it this way. This is just for example. You can choose whatever you like, any approach that you would like to express your vector in the code. And as for the speed, index 0 is gonna be equal to, no need to use the var again. speed row frame rate, speed row, or you can also use the iteration, but since it's only 2, it's not necessary to do that. For me, it's just gonna simply like this. And then as for you chains is also, let's make it just single vector. So it's gonna be 0.0. Basically, this change is the delta in our slide, on the slide. And as for the change, let's see that you want to have the, I'm not quite sure whether we can work this way or not. Change is equal to the change more plus speed. I don't think it works, but let's see whether it gives us some error of yes, it is. Oh, I'm sorry, it does not. I think this is the, you can use this one. Yeah, still error. Oh, I'm sorry, no. It should be, okay. Since we want to transfer vector instead of atomic values, so we need to use 2FV, okay? For 2FV, the second parameter will be vector. Previously, when we use uniform 2F, it should be first parameter, fill it with the pointer, and the second and the third will be the values. But for the 2FV, you only need to specify one parameter, and that parameter should be vector. And it is error, of course, so I think there's no other way than doing this. Actually, later I will introduce you to matrix.js. So using that library, especially when you have already worked with the 3GS, then you may have a better way to manipulate your vectors value. Oh yeah, by the way, this is the 4th meeting. I believe that we need to start our presentation from the week 7. So next week, or maybe by the end of this weekend, we will ask you to submit your team names and the members list of your team. And then later we will assign you the topic. We will draw the topic actually, so randomly. So it's to be fair, to make it fair. And you may start to present the topic of 3JS starting from next 2 weeks. Hopefully, you can make it every week, so we can cover the 8 perspective 3JS topics to help you and your team building the final project. So the presentation, I believe the presentation will also help you to understand the concept of the 3JS better, and you can utilize that, you can leverage that knowledge to support your progress in the computer graphics application using 3JS as your final project. Okay, so this is the way we transfer the value from the JavaScript in the CPU realm to GPU realm to the shader. And now we are using the different type of WebGL API to transfer the value. The value is about the position X and position Y. And now we have this animation run pretty smoothly in 60 frame per second. Maybe I can put some description is here 50 frames per second, or in short is FPS. All right, I'm just gonna store this, save it to my cloud repository. So I successfully animate my rectangle using set interval. All right. Now let me go back to the slide. The next way, the alternative to set interval is set timeout. The way we locate the function is a bit different. The event loop function would be is kind of outside of the set timeout scope. If the case is set interval, it's kind of we have in the same level. So the set interval is the same level with the render function definition. But in the set timeout, we may need to. So I'm just gonna type in here set timeout. Here we need to define the function name. So it's gonna be. So we do not define the function name. So we will just declare a function in here and define it this way. So let's make it this way. And what is previously inside this render function, we will nest it. Nest the lines of code inside this set timeout function parameter. So this is the way we migrate the function timeout, and then the mechanism is a bit different. So this is the way it works. Set timeout will execute this function after specific time specified in here. Okay, and for example, we would like to make it the 30 FPS. Then we just simply, maybe I can type it like, or maybe just using the frame rate. Okay, something like this. So the frame rate is 60. It's gonna be the same. The result should be the same. So let me remove this and change this to render, because we need to call this function once, and then this function will execute set timeout, means that it will call this function once. Okay, again once. So if I execute this or check it on the web, it's like it doesn't move, right? It doesn't move. Why? Because the change is only once. If you want to make it like doing recursively, then you need to call this function again, render this function again. So inside this set timeout, this scope, I put the render function. In addition to the render function, I locate in the main function. Okay, so this should work now. Here we go. You can see in here the rectangle animate the same with the set interval. So good. Then we have successfully animate a rectangle using set timeout. Now, the next one. This is the easiest one, and I just really recommend this for you to work with. Request animation frame. Using request animation frame, you do not need to care about the FPS that you need to specify for the device, because honestly, we do not know what the users will use for running this application on their device, on their place, whether it will they will use head-mounted display with a very high frame rate, 120 frame per second, for example, or using a lower device, maybe the monitor module on the Raspberry Pi that may only can run the graphics for 10 or 15 FPS. Then we just let the request animation frame to measure, to check what is the suitable, the optimized frame rate for that particular device. So how to do that? So we just simply put this out. We do not need this set timeout again. We still need to call the render function once, but however, so you can just preserve this location of the render. You do not need to delete it. You just need to write request animation frame in the front of it, in the front of them, request animation frame, and then put the name of this function as the parameter. So I'm just gonna put, maybe I'm just gonna copy this twice, just once, copy this once to replace the last render function I wrote in the end of the main function. Okay, so we have request animation frame in the end of the render function and request animation frame in the end of the main function, and I put this render function name inside those request animation function as the parameter, and it works. Works just the same like the set interval and set and the set timeout. Maybe to make sure that I'm just gonna remove this, so we do not need to have a frame rate. So wait, yeah, I think to avoid confusion, so I'm just gonna remove this frame rate because we no longer need it. And as for this, it's very fast. Yeah, because it's just the divider is just 10. So I'm just gonna use 600 is one. It's gonna be the same with the previous one. Okay, so here we go, the request animation frame. And if you want to simplify the codes, then I think I do not need to have this mechanism to store. Just put the 3 over 600 in here and 1 over 600 in here, and delete the speed row, and that's all. Is more simple than before with the same results. Okay, so here finally we animate the rectangle with or using request animation frame. What time is it now? 10 to 10. Okay, good. Push it. Now let me go back to the slide. Next is interactive graphics. So that was the looping animation. Now interactive graphics. As a starter, we will use mouse, and we just observe. We try to observe the mouse click for now. We need to type this add event listener, a method from the DOM, to register our function as event handler listening to the click event from the DOM. So this is the most important part. The document.add event listener click between quotes and then on mouse click and then false. Let's have a try. Give it a shot on our main.js file. All you need to do is now, I'm just gonna move to up with above. So before the speed variable declaration and definition, I will create what is this? Freeze. So let's simulate. It's a very simple interaction. So let's assume that we would like to use our mouse. When we click it, it will start and stop the animation. So let's say that by default the animation will the animation is going or running. So that's the default. So let's see that the freeze is false because the animation runs, or the animation is running. Now let's apply some interaction using mouse, and let's declare some function and call it on mouse click. The name is no, it doesn't have to be on mouse click. You can choose any name, but it's just to make me easier to to remember that this function is basically for a mouse click event handler. And after I expect that after I click the mouse, I'm just gonna revert the bool of the freeze variable. So let's do it this way. So I just revert the boolean value. So if it is false, then it's gonna be true, and if it is true, it's gonna be false. And I would need to access the DOM API at event listener and register this on mouse click. I'm sorry, I need to specify the event first. That is a click and on mouse click. It's false. Yeah. If you do not know what the possible events that can happen from any inputs interacting with the document object model, then you can just Google it. You can just Google it. So event DOM at the event listener, I think. DOM events. So here we go. You can check it here. Where's the list? Where is the list? Not here. Oh, DOM event list. DOM event list. Where is that? Oh no, here. Is it here? Oh yeah, this one. Yeah, this one. Document object event. One of them is click. Okay. Now let me check it back to my code, and let's manifest this freezing to our render. So let's say that if it is freezing, or I just freeze. If it is freeze, or if it is not freezing, then apply the changes, right? Otherwise, and you do not need to change the uniform. Otherwise, wait. Or even more extreme, we can just do it this way. If it's not freezing, then you do not need to draw the arrays again and again. Just click. Continue, click. Continue, click. Good. It works. So here you go. So when we click the mouse, then the freeze status will change. And if the freeze status is true, then it will just skip these procedures and just do some infinite empty loop. It's okay then. And once the freeze is false, then it will change the variable and then store it through uniform to the shaders and redraw the things. That's how it works. So how to click to, maybe I'm just gonna click to start our stop animation. Okay, so that is, I think we are about to finish. Hooray! This is the last one. So the same mechanism, we will try to change the freeze status, the freeze value inside on key down. Yet another functions that will be registered to the DOM events. So here we go. Document. Let me create some commentary in here. Apply some interaction using keyboard and define the on key down. And this is the basic and compulsory parameter that you should put in the parenthesis if you want to register this function as a event handler for this particular DOM events. I think all the DOM events should receive the event parameter. In this case, we can capture the if the event key code, I think, is equal to I want to capture space, and the space is 32. And how do I know that the space is 32? Then you can go to the keycodes.info, I think. Oh no. Oh yes. No, without S. Sorry. Keycode.info. And you can click on any tuts on your keyboards, any button on your keyboard to get the key code. This is space, right? So let me go back to my Visual Studio Code. For example, after pressing the space, and it is key down. So I expect that this procedure will only happen when the key is down. It's not down and up, but only while it is down. So while it is down, let the freeze remains. We want to pause it. It's gonna be true then. And let's have another function on key up. Okay. If the event key code is the same, 32, the space. If the space is up, then let's turn the freeze to false. And we need to register this. And event listener, it's for key down and key up. So this is for the key down. It's gonna be false. And the document. I'm sorry, by the way, I forgot why it should be false. But most of the case we use a false. I'm just gonna let you to find it out yourself on the internet. Why it is false. You can check the documentation on our at event listener. And when should we use true? In what case we should use true? You can have a check on the at event listener documentation. And this is key up. And on key up. And last but not least, the false. And here we go. The same mechanism. So I'm just gonna go here. I can use click. I can use space. Release the space. It moves again. Space. If you do not believe me, I press the space. Okay. So it works. And that's all for today. Do you have any question? It's very short. It's very quick course. Awesome. Can finish it in very quick. I hear some voice, I think. Dewangga, do you want to ask question?
Yes, actually.
Okay.
Okay.
Can you raise your voice? It's a bit
Okay.
low.
Okay.
I cannot hear.
When do we start studying 3D
Draw 3D.
making 3D?
Okay, be patient.
Okay.
Be patient. It's gonna be next week. If not next 2 weeks. Because before I teach you how to draw the 3D, I need to teach you about the homogeneous coordinate first and some reviews towards what we have learned from linear algebra. And it's a lot. To be honest, it's a lot, and I may need to spend some times because you need to because my objective of having this course with you is not only letting you understand how the technique, how to code so that you can render something on the on the frame buffer, on the monitor, on the display, but I also expect you to understand the background, the foundation of the computer graphics, so you can understand the logic, understand the story. How come computer can draw something and build something that that basically is the same perspective, the same comprehension, just like we have as a human. And to do that, we need to reflect on we have some review on the linear algebra first. So it's gonna be the next week's topic, and the week number 6, I will start to teach you about the 3D geometry. Anyway, thanks for asking that question. So maybe not only you, but other students also wondering when can we learn about 3D drawing. Thank you, Dewanga. Any other question? Musiska, do you want to have some words, extra words? I'm so sorry. I forgot that you are here, and I should give you some opportunity to speak.
It's okay, Mr. Hazik. Okay. Thank you very much, Mr. Hazik, for your help. No, I don't have anything to say. Thank you very much. The time is limited because we are going to have a visitasi.
Yeah. I haven't yet checked on the text channel. Do we have someone commenting? Oh. It's known. Okay. No comment. Usually somebody will trigger some meme or some jokes, but for today it's okay.
Okay.
Everyone, I think is focusing on the code. Kind of tired actually. Oh, I'm sorry to hear that. Is that because
Dewanga.
the weather is so hot now, Dewanga, or maybe you have a pile of assignments already from other courses? Maybe I'm just gonna stop my screen sharing.
House of Indie Home, sir. It is because of the Indie Home.
Cindy. Okay. Yeah, me too. I'm the Hindi home users. But good stand, because I just heard the updates that today I think many of you experiencing the improvement. So I think the connection is more stable for today because IndiHome ran the lines of Moratel. So they I think they are still fixing their own connections. So the guys under the sea is hasn't yet finished his work or their works. So to complement as an alternative, Telkom, I think, if I'm not mistaken, rent the lines of Moratel, another fiber optics provider in Indonesia. So I think that's it actually, guys, for today. I'm so sorry that I forgot to start the session with a prayer. So that's condition. Okay. Hopefully it gets better. You got better, Dewanga. Okay. All right. Let's close the session, guys, with the pray. Let's pray together so that we can benefit a lot from these blessing moments, and we can meet each other again next week to continue our journey understanding computer graphics. Let's pray together. Okay. Thank you very much.
Excuse me, sir. Last question.
Hello, Gary. Yes, go ahead.
Yeah. Would we will we learn about quaternion rotation?
Yes, I will teach you the concept of quaternion.
Okay.
But before that, I need to explain about first about the homogeneous coordinate and 3D geometry, because quaternion is 4D geometry. For your information,
Yes.
is 4D geometry, something that we cannot imagine visually actually.
We
but
cannot
it's
see
gonna
any
be
evil.
very awesome. Yeah. uh, is in a technical word we can call quaternion is like a hypersphere. Do you know sphere? Sphere is bola. Bola is in 3 dimension. Circle is 2D. Lingkaran in 2 dimension. And quaternion is actually hypersphere. It's a sphere in the third dimension, in the fourth dimension. So to understand that, you need to understand the third dimension first, and also some concept of homogeneous coordinate. Okay, thanks, Gary. So that's all, guys. It's a wrap. We'll see you again next week. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you.
Thank you very much, Mr. Haziq.